My name is José Sérgio Almeida. I work for the Brazilian National Institute for Space Research, INPE, located in São José dos Campos, São Paulo, Brazil. Today, I will talk a little bit about the basics of spacecraft technology. Okay, let's talk a little bit about more complex spaceships. This is very interesting to recall the phase we are today after that first spacecraft in 1957. So we are getting this amazing level of high technology. I'm going to show you here an example of a very, very precise and technology that we got through NASA sending a large rover to Mars surface. So it's called Curiosity. It's a kind of rover, it's a big, talk about 900 kilos. We sent this spaceship. It took more than 8 months to arrive the Mars surface. So then we deployed safely a large rover in that surface. So we can see here in this graphic here, they had to program an automatic way of landing in that surface because the distance was so big, they cannot do a communication to do a real-time operating condition to land safely the rover on top of the surface. They had to do a programming automatic landing operation using sensors that they collect real data in real time over there to update the software information to readapt the condition of the spacecraft descending to the ground of the Mars to make sure it's going to be a soft landing on the ground. Okay, now I'm going to show a video that was made before, of course, descending this Mars rover to that surface of that planet. We can see the way it operates to descend and to place safely a rover on top of the Mars surface. It actually happened exactly like this. Otherwise, the rover was landed safely condition. We know today it landed safely because it's working in Mars surface. So it happened exactly like this. So it's amazing the way NASA people did this job. It's incredible. It's a remarkable achievement of humanity. As I said, 8.5 months of traveling to reach the Mars surface. So it's a large spacecraft to reach in that area in a very high speed. So the first thing is to have to decrease the speed while entering the Mars atmosphere. So you can see here, decreasing the speed while entering the Mars atmosphere. So it's a very large amount of energy to reduce the speed of the spacecraft after this long-term fly to that planet. So this part of the spacecraft will be very hot because of the shock to the atmosphere. But even though we need to slow down to reach the surface. So the first thing is to use a parachute system. But because the atmosphere in Mars is very weak, the parachute will be not enough to hold the spacecraft. As you can see here, it's very, very fast. So we need something else to decrease the speed. So what they did is to deploy some kind of thrusters to speed down the spacecraft while descending. As you can see here, they use several thrusters to decrease the speed while approaching the spacecraft to the surface. But even this situation could be good enough because the thruster could be damage the rover while touching the ground. So the solution those guys found is to deploy the rover using cables to put it further from the thrusters. That's what they're going to do right now. You can see they're deploying the rover using cables to make it further from the thrusters. And then once the wheels of the rover will touch the ground, all the cables will automatically cut and that upper part of the thrusters will be sending far away to do not disturb the descending. Okay, have a touchdown, cables cut, and that equipment part of the spacecraft is sent far away. So that means they found a way to land a 900 kilos rover land in the Mars surface in a safe mode. Just very remarkable, very incredible, in my opinion. It's good. So this is a artistic conception the NASA guys did before the flight of the rover to Mars. They expect that this could be an image of their rover on the surface of Mars. And then what happened is the rover itself, the Curiosity, made a selfie portrait of him using the arms it has. So you can see here is very, very close of the drawing they made before the trip. So you can see it's amazing. They have the rover sit on the ground of a Mars surface, doing all the experiments over there. You can see movements on the ground, and this picture shows where it is. Where is it right now? So in the right here, I have a picture. I'm just beside of the rover at NASA facilities just to show you the size of this rover here. It's a big size, as I said, 900 kilograms. So it's amazing technology to put this kind of a rover on top of a Mars in a safe mode. So it's just incredible the technology we got after these years since 1957. Just a picture that the Curiosity made a few years ago. It's a panoramic view of the Mars surface. It's incredible to have this view here in this quality of image we have from that particular experimental rover placed on Mars surface. Okay, another incredible achievement we have recently was the landing of a robot called Philae on the surface of a comet. So after traveling over 10 years to chasing to reach a comet, it's called 67P, so it's about 500 million kilometers away from the Earth. So the mother ship was called Rosetta, made by ESA, the European Space Agency. So finally reached the close to these comets, and then keep orbiting the comets, and eventually he delivered a small robot called Philae, right? And then this robot managed to touch the surface of this comet safely. But remember, all of them are 500 million kilometers away from Earth, and all of them they're cruising at about 66,000 kilometers per hour. So this maneuvering of detaching the Philae robot from the mother ship Rosetta and touching the ground and staying the ground of this comet was a remarkable achievement of technology, space technology as well. In the right size, there's an image produced by this Alex Parker just to show us, give an idea about the dimension of these comets compared to a small village in the ground. Okay, so it's a big size of comets. So this robot called Philae, is the size of a washing machine, for example, is now attached to the surface of this comet here, waiting to get sunshine to repower the batteries to starting giving us information about the surface of this comet in the near future. Okay, let me talk a little bit about the International Space Station. It's the largest spacecraft we have in space today. The size is about 110 meters, so it's a very large spacecraft. It's orbiting in about 400 to 450 kilometers altitude. So in fact, it's a large laboratory we place in orbit. So there we have few laboratories like American laboratory, Russian laboratory, Japanese laboratory, ESA laboratory, for instance. Canada also has a laboratory over there. So they can have astronauts and cosmonauts doing research over there because it's a kind of a permanent laboratory in space. As you can see in this image here, has huge size solar arrays because they need a lot of power to maintain the laboratories in proper operation in space. So this is very large. We can see it from Earth here visually at nude eye while orbiting. Okay. Another image, you can just to give an idea the size of this, let's say, spaceship. You can see how large is the spaceship compared to the, let's say, a football field. I'm talking about 110 meters, and the mass of this spacecraft is about 450 tons. So it's a large spacecraft in space where we use a lot for experiments in space and also preparation for future journeys to another planets. In this picture you can see an example of the laboratory. It's a way to do in situ experiments under microgravity conditions. Okay? So here we can do experiments like medicine, biology, physics, chemistry, and also new materials, because getting rid of the phenomenon of gravity, we can produce new materials, different situations than we can produce in Earth conditions. So also, of course, is used for Earth observation. They can have a nice view from the Earth, as I showed before for the hurricane, and as I told you here, also is a stage of preparation for future interplanetary journeys, like say to Mars and beyond, who knows, in the future, because they can prepare themselves there. One critical conditions are the muscles and the bones of the cosmonaut, because if they stay longer in space, they have problem with bones and problem with the muscles. So they can do a better analysis while inside the space station to see what can be done to mitigate, to minimize this problem of bones and muscles. We should not forget to mention the space shuttle. Although it's retired, it's amazing, incredible technology behind this spaceship. You can see here an image of it. So we reach a high level point of technology to put the astronauts in space and return them safely to Earth. Like here, we can see image of the space shuttle taking off, then going to space and reaching the International Space Station, attaching to the space station, and then after doing the job, returning safely to Earth. So it's just incredible, remarkable spaceship that was produced by United States. So today's retired, but we have to remember this is incredible technology behind this spacecraft. But now NASA is working on new technology, new spaceship to send astronauts to Mars. So it's called the Orion spaceship. So it's going to be a little larger. You can take more than 3 astronauts to Mars using a very large rocket, as you can see here in the left bottom. So last December they performed a first test, launching, orbiting, and re-entering to Earth this kind of spaceship. So they're getting ready for a long journey to Mars, eventually sometime in the future. This is a new technology. It's incredible, remarkable to take astronauts up to Mars and return them back to Earth safely. Okay, let me talk a little bit about education. Of course, we have many disciplines that we can recall, remember, that is applied or involved with space activities. We can, of course, remember about mathematics, physics, chemistry, of course, and computing all the time, geography, biology, history, and politics. More and more talk about history here because things are changing so quick, and social science as well, because it involves different countries, and economy, administration. You can see the amount of funding is located to the space technology. So law and diplomacy, more and more, because we are remote sense in different parts of the Earth. So we have to discuss about how we can do this, how we can watch different countries from the space. And physical education, medicine, of course, because as we are talking about going to different places in space or even other planets like Mars, so we have to understand better about our body in space orbiting situation, or even tripping to another planet like Mars. Another example of education is, like, say, for children, they can easily go to Google Earth today and see the whole Earth. They can focus on different countries, different cities, different places in surface. They go zooming, so it's a very good, useful tool to understand our planet in an educational situation. So this for children, for study, is very good tool, very reliable, good tool. It's a good use of a spacecraft imagery. Okay. Another benefits from space exploration. Let's just recall. Here I put an image produced by this guy called Apian. That's what's in 1544. It's a long time ago. this person tried to draw an image of what he thought was the surface of the earth that time. So he tried to put some continents here and there. You can see roughly one or another continent here. It's just a guess of what could be the surface of earth. But that was the condition he had at that time, 1544, it's a long time ago. But now what we have an exact image of our home planet. So this image is made by satellites. So there's no doubt about this anymore. This is the way exactly our home planet is. So it's a good use of spacecraft from space. You can get a very clear and nice image like this one here, so we know exactly how our planet is. Okay. Another nice image from Earth here, the night. So it's made by spacecraft. You can see the lights on the more have more lights in this certain region of the planet. So this is another image that shows us that in 1991, when the Voyager 1 spacecraft was launched in 1977, it was over 4 billion kilometers away from our planet. So it took an image from the Earth. So you can see how tiny pale dot we are in space, very small. So you can see from very distance, we are very small compared to, of course, in the whole solar system. Okay, so this is just to give an idea about where we are in the universe. So this is just to give you an impression the distance a spaceship can fly to get the imagery from the Earth. So that is mainly this particular presentation. Thank you for your attention. So I hope you enjoyed. Thank you.